In this tutorial, what we're going to be covering is the use of the variable grip scale factors and bump scale factors to basically dial in our simulation. Alright, so what we have here is we have a comparison of a simulated lap against an actual lap. And as you can see, in most sections it's pretty much close. There are just a few sections that we need to tidy up on, namely in here, into turn 1, and into here. So, to facilitate that, what we're going to do is we go into Chassis Sim, and we go into View, and we go into Circuit, Edit Variable Grip Scale Factors, and what we do is we'll load in our track, and we'll load in the bump profile that corresponds with that, which was bump profile C. Okay, so what we're going to do now is that we now have our curvature and bump profile loaded in, and from this way we can match up the grip scale factor to the curvature file and the bump scale factor to the bump profile. Now, when looking at how to do variable bump scale factors, what we need to do is we actually need to take a look at the two offending bits of the circuit. And for the purposes of this tutorial, we're just going to focus on turn 1 here and on turn 15 here. So our first port of call is to dive in and have a look. Now, as we can see, we've got some, as you can see with this set of data, we do have some noise issues with the actual the actual damper, and the fact that we can tell that the outside current dampers are moving significantly more than the insides. So what we're going to do is, usually your first port of call when you're looking at playing with variable bump scale and grip scale factors is to play with the bump scale factors first. So what we're going to do is we're going to apply a bump scale factor of about half from about, we can see here, the 360 meter mark through to, as you can see, where we backed off the throttle to about the 544 meter mark. Now, the reason we're doing that is that Chassis Sim adopts basically a first pass, is basically pretty much a one strike and you're out policy with regards to pumps. So basically what we want to do is we want to basically tick off any area of error that we could be getting. So what we do is that we basically go back to our variable grip scale factors, and basically using the right arrow key, you'll see here we increment the distance until we basically hit until we hit our desired section. So from here, I'm going to hit the shift key and keep it held down and go to about the 544 meter mark. Once that's done, I hit the tab key, and this brings up my local grip scale factor and my local bump scale factor. For the time being, I'm going to leave the local grip factor at 1, but I'm going to change the bump scale factors to 0.5 and 0.5 respectively. I'm also going to do the same thing for turn 15, just going back to the comparison of our data. You can see here that we probably need to scale up between about the 55 meter mark and about the 38 mark. We'll call it 40. So going back with the left arrow key, okay, so we'll go from the 34 meter mark to about 40 meter mark. Hit the tab, we'll do the same thing. Okay. Once we're done and we're ready, we basically click on the tab that says Generate Grip Factors. We click on Variable Grip Factor, and what we'll do is we'll basically call this Grip Scale Factor Sebring Demo. And with the Bump Scale Factor, I'll just change it to star.dat, and we'll call this, and we'll call this Bump Scale Factor Sebring Demo.dat. And we'll click on OK. So that basically has generated our variable grip scale factor file and our bump scale factor file, which is basically just two ASCII files. Now, you have to generate both, and there's actually a sound reason for doing both. So what we now do to load those files up, we go into circuit data, and you can see that I've already loaded it up. But we basically, for the grip scale factor, we click on Import Grip Scale Factor, and we've got Grip Scale Factor Sebring Demo. We import the Bump Scale Factor, and we change it to filter star.dat. We go bump scale factor Sebring demo, click on open, we click on use grip scale factors and use bump scale factors, and we click on OK. We go to the start button, and we start and we go to start simulate. I'm not going to do that right now because I've already done it. So basically, what we then do is we basically take a look at basically the difference that made. So I'm just going to bring that up. Just going to overlay the actual data to the real data, and as you can see, we definitely have tidied it up, but we've basically got a bit more work to go. Now, just moving into what the actual dampers are doing, as you can see, we've certainly toned down what the dampers are doing, so I'm a little bit reticent to take off a little bit more bump scale factor there. So my next job will be to add grip scale factor. Now, here's where you can have here is where you can apply a very, very handy trick. Because we've already generated the grip scale factor, all we've got to do is go into Microsoft Excel, load up our grip scale factor file. I'm just navigating to the location of this file. We look on grip scale, we go to open, we'll go delimited, it's space delimited, next, finish, and all of a sudden we've basically got our grip scale factors here. So what we can do is that going back to our data, we can take a look. For the first parts there, it's actually doing pretty. For the first parts there, it's actually doing pretty all right. So between about 440 meters and basically where we're basically backed off on a minimum throttle, which is the 556 meter mark, what we can do is that we can go here and we'll change that to say 1.3, because there is still a bit of discrepancy on the speed, to here to 1.3, and we'll basically linearize that. And we do the same process, and looking at our data, here once again, I really don't want to scale down those bumps any further more than what I have to. So you can see here that I've got about an actual speed of 146 kilometers an hour, plays about 138 kilometers per hour. So I'm just going to up that scale factor to about 1.2. So we go back to here, to where our relevant speed marks were, which was about between 5340 meters and 5440 meters. So I'll just change that to 1.2, and I'll change that to about 1.2, and now I'll just delete that, linearize, and what I will do, just as a point of habit I have, I'm going to save this as grip scale factor demo 2. Okay, so what I'll now do is I'll go back to circuit data, and I will now load that new grip scale factor in. So that's now loaded in, and we're good to go. And once again, to start the simulation, I simply click on Start Simulate, etc. Now, I've already done that previously, and as you can see, I'll just get rid of this, and I'll load in basically that simulation of those grip factors. And as you can see now, particularly in turn 15, we're an awful lot closer. We've still got a little bit of work to do in turn 1, but really the point of this is to illustrate the process of how you go about scaling grip scale factors. So reviewing, what we do is we dial in the bumps first, and then once the bumps are relatively within reason, then we start playing with grip scale factor. Then we start playing with grip scale factors. Now, the reason that we're doing this manually is we don't want to be in a situation of where we wind up by basically chasing our own tail, or being in a situation where we're trying to basically plug gaps in the model. So, but your biggest influence when you're using grip scale factors is that you get the bump scales right. Once you got the bump scales right, you then move on to grip factors. Now, just a point that I'd like to make about the bumps here. As you can see here, we have slightly down-tuned what's going on with the bumps, and that's been for two reasons. Number one, the fact that this particular damper data isn't particularly reliable, but also sometimes when you're simulating, you need to be in a situation where you don't want to be you don't want to take the old English analogy of in cutting off your nose to spite your face. Just remember, Chassis Sim does adopt a one strike and you're out philosophy. So sometimes what we might need to do is we might need to just downgrade the bumps a little bit, so that we're not tripping over on any unnecessary bumps.